Hello everyone and welcome back to another Advent of Code video. The response to day 1 part 1 in Elm was really good, so thank you very much. I hope that was useful. And so today what I'm going to do is record the first part of day 2, which I'm going to do in Elm. Now I decided to do the first part of day 2 rather than continue with the second part of day 1, simply because the first parts are generally a bit easier, and that means it allows me to talk a bit more about some of Elm's features and talk you through it a bit more. The second parts are a bit harder and take more time, so I don't feel like I have as much time to properly explain things. So rather than do the more complicated bits, I'm going to try and do more of the part 1s in Elm, and hopefully that's an easier place for you to learn a bit more about the language. So today's challenge is an inventory management system, and there's a bit of a backstory that I won't read. You can read it yourself online. But what we have to do is look at boxes or box IDs and see how many times given letters occur in them. So for example, if we take this one, BA, BA, BC, we should be able to read from that it has 2 A's, 3 B's, and then 1 C. And what we need to do is we need to take a list of these box IDs and find the number of entries that have exactly 2 of any letter, and then separately count those with exactly 3 of any letter. And then we need to multiply those together. So here's our dummy input can be these ones here. And it says of these box IDs, 4 of them contain a letter which appears exactly twice, and 3 of them contain a letter which appears exactly 3 times. Multiplying these together produces a checksum of 4 times 3 that equals 12. So we need to take a list of box IDs, figure out the frequency that letters occur, and then multiply 2 numbers together to get our checksum. And we have our big long puzzle input here. But we're not going to work with that as normal, we're going to take something more straightforward. For now what we're going to do is take a string and pull out the frequency that letters occur in that string. Looking at the challenge, we don't care about letters that appear only once or that appear more than 3 times. We need it to be exactly. But what we're going to do first is have a function that can take one of these strings and return us a dictionary containing the letters and the number of times that letter occurs. So for now what I'm going to do is I'm going to take, let's say, this one as my test string, and we're going to write a test. So I've got a very similar setup to the first video. I have some tests here, and I have my main.elm, which is empty. So we're going to start with a test. So it's day 2, and this function, this is going to be count frequencies of letters. Let's go for that. So we'll take our input, which is going to be just this single string. What we're going to do is we're going to call main.count frequencies of letters, giving it this string, and we'll pipe that into what we expect. And what we expect is something that in Elm is called a dictionary. It's kind of similar to a JavaScript object in a sense. The reason we can't use an Elm record here, which is what maps most closely to a JavaScript object, is that Elm records have fixed keys they're at creation. So once you create a record with a certain set of keys, you cannot add or remove to it. So this is not very good when you need to go over and update values and add keys as you find a letter. So we're going to use an Elm dictionary. So we can import dictionary. It's a core module, but it needs to be imported. And let's set up what we actually expect here. So we're going to expect it to equal dict.fromList, and now we're going to give it a list of all the keys and the values we expect. So this is a list of Elm tuples where the first entry is the key, so we're going to expect that the first letter will be B because that's the one it comes across first, and it's going to have 3, and I'll paste this a couple more times. So we've got B that's 3, A needs to be 2, and finally C needs to be 1, and I'll get rid of that trailing comma, save that, and that looks about right. So it's moaning that we don't have this function defined. So actually, if I run Elm test now, we're just going to get that error. Cannot find that. So let's go and define that function. I've also got this input.elm file. This is where we'll put the actual puzzle input, but we'll ignore that for now. In fact, let's just move it over here so it's a bit more out of the way. So let's go and expose here count frequencies of letters. It's going to take a string as input, and it's going to return a dict. And a dict takes 2 types with it. The type of the key, which will be a string, and then the type of the value, which will be an int. And thinking about actually, we don't even need a string here because a string would let us have multiple characters. Like this could be in our dict. And we know that's not allowed. We know it's only ever going to be a single letter. And in Elm, double quotes mean strings, but a single quotes means a single character. So actually, we can make this a dict of chars to integers, which would make it a bit more type reliable. So let's define it like so. And we'll have count frequencies of letters. It takes an input. And now we're just going to return dict.empty. And I need to import the dict module, and I'm going to expose the type dict. And up here, this exposing hello is changed, so this needs to become count frequencies of letters. Okay, let's clear that and run elm test again. Okay, the argument is dict, oh yeah, char, and it's asking for a string. So this is because we changed our type here to be char, and now in here I'm using the string. So if I just go and select these and change them for single quotes and hit save, and I'm going to set elm test running in watch mode now, the -- watch flag. Great, and you can see we're getting an empty dict, but it's expecting this dictionary in place. So what we need to first do is take the string and split it so we can go over every single character. We used string.split last time for our big puzzle input. We're going to use it to break up this string, and we're just going to do it, if you pass string.split, the empty string, it will split on every single letter. So we're going to take our input, and we're going to say string.split on the empty string. And I'm going to do the logging trick again, so we'll say new input. And let's put some brackets in there, and then in here we can do let _ equals debug.log new input, and we'll just say in dict.empty. We run that now, you can see we get there all the letters as one. So what we need to do is we need to reduce this list, and we need to go over it one by one, and if it's a letter we haven't come across before, we need to put it into our dictionary and set the count value to be 1. If we've seen it before, we need to pull the value out, increment it by 1, and put it back in the dictionary. There's a couple ways we could do this. We can use reduce, which is what we're going to use, but we could also recursively do this as well. I'm going to go for reduce because it's what I would do in Elm. I think it's what Elm would encourage, but you could do this recursively as well. You could have functions that pull one letter off at a time and go through it, but we're going to go for reduce. So we're going to split, and we're going to go list dot, it's not reduce, it's called fold L in Elm, but that is the equivalent of reduce in JavaScript, say. So we're going to fold, and it's going to take the current letter and the accumulator, which I'll call frequencies dict, and that in there is going to have to return something, so let's now just return the frequencies dict. And then remember it takes the argument, which is the starting dictionary, so we can say dict.empty, and the final argument is the input, but that will be passed in via the pipe for us. So you see now our new input is dict.fromList. So what I'm actually going to do now is get rid of this logging, because now we can just run it against a test. Okay, so in here we need to look up in the dictionary if we have this current letter. If we do have it, we need to update it by 1. If we don't have it, then we need to return just insert a new key with the value. So let's go and look at the dict package on the Elm package repo and see what functions are available to us. So I'm on the package Elmlang's site. Just a little tip, if you're ever looking for a module that's kind of built in, it's always in the Elm core package over here. So you click on that, and you see here you get all the default kind of modules. You'll see here it notes which ones are actually imported by default. So you'll see you have these imports for you, so you never need to do them yourself. You'll see that dict is over here and is not imported. So we always need to import dict. So let's look. There's empty, create an empty dictionary. And here we have insert, which inserts a key value pair into a dictionary and replaces a value when there is a collision. We also have update, which will update the value of a dictionary for a specific key with a given function. So update could do it. The only thing that's not clear to me is if update will deal with the fact that there isn't a value. But it looks like it will, because the second argument is a function that takes a maybe value and returns another maybe value. So the important thing to note about dict is when you fetch a key from it, if we find the function here get, you get a maybe back. Elm doesn't have a concept of null or undefined, as we touched on in the day 1 video. So if something isn't found, it has to return something. And the way it does that is by wrapping these things in a maybe type. So you see here, if you take a look at this animals dict, where Tom is a cat and Jerry is a mouse, if you get one that doesn't exist, you get back a nothing, else you get back justs. So it looks like what we can do with update is we can do that, and we can have the function deal with the fact that the value may be missing. If it's missing, we'll just return 1. If it's not, we'll add 1 to it. So let's go with that. I think that's going to work, but there's only one way to find out. So in our fold, what we're going to say is dict.update. Now dict.update first takes the key for us, which is current letter. And then it's going to take the function to handle the value. So let's put in value. And for now, what I'm going to do is say let _ equals debug.log got value in value. So we'll just do nothing. It's effectively the identity function. And then it's going to take the dict, which will be the frequencies dict. So let's say that we get an error here. The body is dict string int, but the type annotation is dict char int. Of course, this is because string.split is splitting the string into single letters, but it's still leaving them as strings, so we need to map them into chars. So I'm in the char module documentation here, so we can see lots of functions that aren't really helping us. Here's conversions. No, it doesn't look like any of those. So it might be in the string package. It's going to look in there. Here's empty length, building and splitting. And after digging through documentation, I finally found it. I'm sure you saw it earlier than me. In list conversions, we have toList. So we can call string.toList, and it will take our string and convert it into a list of characters. So rather than doing what we're trying, which is string.split, and then trying to convert it, we can do this instead. Thinking about this makes perfect sense. It wouldn't make sense for there to be a string.toChar function, because a string could be any number of characters, and obviously a char has to be just one by definition. So Elm would have to wrap that up in a result or deal with a failure case. So actually, most often we're going to want this. So we can use string.toList instead. So going in here, if we change string.split to string.toList, we don't need that map, and you hit save. We're now compiling, and you can see we're logging got value nothing. So you can see that it's finding in the dict that there is no value for the key we're looking at. So what we now need to do is take this dictionary, and in the in we return the new value. So what we'll do now, just to demonstrate that this is working, let's just return just 1. That's the new value that we're going to return on each test. So you can see now what we're getting is a list where A is 1, B is 1, and C is 1, and we're expecting A2, B3, C1. So what dict.update is doing is saying, okay, fetch me the value for this current letter, wrapped in a maybe. And what we'll return is just 1. And this return is what will be put back into the dict. If we return nothing, then nothing will be put into the dictionary. So this would be useful if you wanted to conditionally put something into the dictionary. So what we need to do is check if the value is nothing. If it is, return 1. Else, we're going to map it and add 1 to it. So inside the value, I'm going to pattern match against the fact that it could be nothing or it could be a value. So I'm going to say case value of, and if it's nothing, then we want to return just 1. And be careful here, it's just 1, not literally the number 1, because 1 isn't a maybe type. We need to put it inside that maybe box. And if it's just x, then what I want to do is return just brackets x plus 1. So we'll increment the number by 1. And if we run the test now, you can see that the test is passing. So we're correctly populating our dictionary as we loop over the list. Okay, so that's part 1 done. We now need to do the bit where we take a whole list of these and calculate the frequencies for all of them before summing up the ones that meet our criteria. So I've gone back to the puzzle input, and what we're going to do is we're going to use these as our test case because we know what the answer is. It should be 12. So let's go back to our test. I'll say part 1 test input. And this is going to equal 3 quotes, add another 2 there, and we'll paste that in. And I now need to do some multi-cursoring. So let's just select this word, go all the way down there, back, and delete those. So now we have all our inputs. So let's describe day 2, and we'll add another test here that says test, it calculates the checksum correctly. So we're just going to do a slightly big unit test that just proves the rest of this part is working. So it's a function, and we'll say .main.calculate checksum for part 1 test input. And we know from the documentation on Advent of Code that we should equal 12 from doing that. And it's going to error because calculate checksum doesn't exist. So let's go down here and define calculate checksum. It's going to take a string, and it's going to return an int. We'll do input, and for now I'll just return 0. We need to go back to the top here and expose this. So in Elm, you have to name explicitly the functions that will be exposed by a module. By default, they're private and can't be touched by any other module. So let's take our input, and we are going to do some string splitting and mapping here because we need to map it into the individual strings so we can map them through our frequencies function. So we're going to do string.split on a new line. And we're going to do our filtering trick again. So we'll say list.filter, and we'll do not, wrong around, string.isEmpty not. So that will pull out all the strings that are still empty. And I'm going to do the input debugging trick again. So we'll say new input let underscore equals debug.log. I should reset up a snippet in VS Code for this. New input, whoops, that one, in 0. Let's just save that. So we go, we have our input, which is our list of strings. So now we can map all these over our count frequencies of letters function. So we say list.map count frequencies of letters. Save that. You can now see we get this new input, which is our big list. Now what we need to do is go through each of these and pull out the bits of data we care about. So the bits of data we care about is if the string has a letter that appears exactly twice, and if the string has a letter that appears exactly 3 times. And then we need to get the total number of strings that contain a letter twice, the total number of strings that contain a letter 3 times, and multiply them together. So what we need to do is take one of these dictionaries and pull out a true or false value for does it contain a letter twice, and does it contain a letter 3 times. And this can take our dict and return true or false. So let's go in here and we'll say calculate, let's call it twice and thrice. Or let's say does input contain letter twice. Let's just write the twice one first. So it's going to take the dict of char to int, and it's going to return a bool. So does input contain letter twice? We'll say frequencies. So we're going to have to go through our dict and see if we find any where the value is 2. Looking at the dict package on the Elm package repo, we have this values function. It takes a dictionary and pulls out all the values. So this is all we need to do. We need to go through those values and see if there's a value with the number 2. So in here we can say frequencies. We'll do frequencies, and we'll pipe that into dict.values, and we'll do list.any. So we'll pull out the value, and we'll say v, and we'll say v equals to 2. So that does input contain letter twice. We can create another function here, and we'll change twice to, whoops, too many times. If I get my keyboard right, we'll change twice to thrice, and we'll say here v equals 3. And now what we can do is we can map our dictionaries into a record in Elm that just has these 2 values in. To do that, I'm going to create a type alias. So type alias is useful where you have a record with a particular structure and you want to pass those around and create your own type for them. So I'm going to say type alias. They have to have a capital letter as well. Let's call it frequency match will do for now. And we put an equals there. And we're going to say it's just going to have a key called twice, which is a bool, and a key called thrice, which is a bool as well. And so what I'm going to say is we're going to have a function that goes frequencies to match, which is going to take the dict of char to int and return a frequency, not that one, and return a frequency match. This naming isn't great, but we'll roll with it. So it's going to take the frequencies, and we're going to return twice, and it's going to equal the does input contain letter twice function with frequencies. And then we're going to have thrice, which equals does input contain letter thrice with our frequencies. Now, if you're worried about efficiency here, you might have spotted an issue in that we're doing this by going over all the frequencies twice, once for this time and once for this. I'm not going to worry too much about performance here. If this was something we were worried about, we'd want to combine these into a way where we only did the check once. We could do this in here by returning more than a bool. We could return these objects directly, but I'm just trying to split it out into smaller functions for the purposes of this video. So now we have this. What we can do is we can say list.map, and we can say frequencies to match. If we hit save and let that run again, you can now see we have thrice equals false, twice equals false, and so on, true, true. Now we need to count the ones that have thrice as true, then count the ones that have twice as true, keep those 2 counts and sum them up. So let's do this in a reduce or a fold. And so the accumulator here will actually be a tuple of the 2 values, once for the twice value and once for the thrice value. In fact, a tuple is a bad idea because we want to name them. So what we'll do is we'll reduce into a record of twice equals 2, thrice equals 3, and we'll update this on every part of the reduce step. So let's fold. And when we fold, we get the current value and we get the accumulator. And I'll just call it that for now. And we'll just return the accumulator. And our initial starting accumulator is going to be a record where twice is 0 and thrice is 0. And now if we run it, we'll say new input thrice equals 0, twice equals 0. What we can do here is we can pull the values out and write a case statement on them. So we'll say, I'm going to destructure and we'll say twice, thrice equals current value, and that's going to destructure the two keys out of the record. And then we can do a case statement, and I'm going to say case, and I'm going to create a tuple of twice and thrice, because then I can match on them. And so I can now match the case where they're both true. And if they're both true, we need to return a record where twice is going to be accumulator.twice plus 1, and thrice is going to equal accumulator.thrice plus 1. You can probably see where we're going here. If twice is true but thrice is false, then what we want to do is we'll actually update this. So we'll return the accumulator, and this is how we update a value in an Elm record with this pipe syntax. And here we'll say twice equals accumulator.twice plus 1. If we swap these around, so rather than twice being true and thrice being false, it'll be twice false, thrice true. We can now swap this twice here for thrice. And finally, if we get to the final case where it's false and false, we're just going to return the accumulator because we don't need to add any of these to our counts. Accumulator. Okay, and I think this is indentation, just need to bump that in. And I've left that accumulator there by mistake. Okay, so you can now see new input, thrice equals 3, twice equals 4, which is perfect. So now, rather than map over this and output here, we're just going to change this, and we're going to return new input.twice plus new input.thrice. And that should have our test, hopefully, passing. And I've got 7, that's because I've added it, and of course we need to multiply it instead, and that will give us 12. There's a bit of kind of improvements I would do here. You can destructure in function arguments, so I can say twice, thrice here, and then we can take this new input bit and just delete it. And that will even then go on one line, which is quite nice. And this is a really good demonstration of how Elm's pipeline syntax and its list functions make it really easy to take some data, map it and transform it over and over again to get the result you need. Of course, this might not necessarily be the most efficient way. You can imagine ways we would do this where we'd loop over the list fewer times, but it's pretty good for us getting to our solution. And similarly, we can do some destructuring here. So rather than doing this current value in a let, I would probably do this up here. So we'll swap this current value for twice, thrice, and then we can get rid of the let block. That tidies things up a little bit, and we're still passing. And you might be tempted to pull this out into a function as well to refactor. I'll leave this as an exercise for you. I'm going to leave this as is for now. So now what we should be able to do is get our proper puzzle input, and we'll have day 1 completed. So let's grab this and copy it. I'm going to my input.elm, and we'll just paste this in here. And we'll just tidy up the white space there. Okay, so if we go into main.elm, let's define part 1. And part 1 equals calculate checksum of input.puzzleInput. So let's now go and open a REPL and say input main. And we should hopefully be able to say main.part1. And it cannot find it, and that's because we're not exposing up here. So let's expose part 1. Let's import it again. And it's 7776. Let's copy that. Go back to our Advent of Code input, paste it in, hit submit. And we are correct. So that is day 2, part 1 in Elm done. As I said, there's definitely some tidying we can do here. So let's just do a couple of small refactors. I'm going to swap back to the tests. I love refactoring whilst having the test running just to make sure we haven't broken anything. So we can probably pull this function out that actually updates the dictionary, or at least particularly this bit. So what we're doing here, we're going to say increment or insert letter count, and it's going to take the char and the dict of char to int, and it will return the dict as well. So it will return a dict of char to int. So increment or insert letter count will take our letter as a char, and it will take the frequencies. And it's basically going to be this update function. So let's yank that and put it up here, and just put it over a little bit more. So we'll update on the value of letter, and this frequencies dict will become frequencies. This now means I can pull this function out into instead a call to increment or insert letter count current letter frequencies dict, and make sure our tests are still green. They are. You'll notice here that we have an anonymous function with 2 arguments that we're just calling another anonymous function passing those 2 arguments on. So in the case of that, we can always simplify it down to just the name of the function itself. So I can make this, tidy that up and delete that and that, like so. So this is much cleaner. We're just folding with this function and starting with an empty dict. It's much cleaner. If I was writing this as well, I would normally pull frequencies up to the top and pipeline it. I tend to prefer the pipeline approach if the value frequencies, if we weren't pipelining, is down here. The reason is because if I have it like this frequencies is quite far away from the original function call and it can get unclear. I think with the pipeline it's much clearer and easier to spot. There's a couple of improvements we can make to the does input contain letter twice and thrice. There is a bit of duplication. We could create a function that takes the number it should match against. But what I want to do is just show you a bit of Elm's partial application. So here we're actually calling a function, double equals, passing 2 and then the value. So in Elm, any functions like this are able to be called in this style where we put one argument on either side. But that's just Elm special casing. What you could also do is if you have 2 equals equals 2, in Elm that's the same as wrapping the double equals in brackets and calling it with the 2 arguments. It's just syntax that lets us do this. It's just a syntax sugar. So what I can do here is I can say list.any and replace this with the double equals function and partially apply it with the one argument, which is 2. You can see that gets us the same result, but now the anonymous function is just being built for us because we're partially applying double equals. So I'll make the same change down here too. Be careful when you do this, you need to wrap the double equals in brackets. If I fail, then you'll see we get a passing error. So there we have it. All the code will be on GitHub for you to look at. I'll leave a link on the video now. I hope you enjoyed it. Let me know if you have any questions, and thank you very much for watching.